Welcome to Section 7.7, Part 1. This is the 58th session of the CISSP exam prep series. This part turns theory into practice, applying cryptography to devices and email. In this session, we'll put cryptography to work. We'll answer several questions. How do you protect data sitting on portable devices? What does a trusted platform module add to that protection? How do you decide what security an email actually needs? How does pretty good privacy build trust between users? And what makes MIME different? Why does this matter beyond the exam? Because these are the everyday problems you get handed on the job. A laptop goes missing from an airport lounge, and your first question is whether its disk was encrypted. A leadership team wants confidential email that recipients can prove came from them. You are the person expected to pick the right tool and configure it correctly. Knowing how these applied controls work turns vague requests into concrete, defensible decisions. So how do you protect data sitting on portable devices? Laptops, phones, and tablets carry sensitive data that can walk out the door in seconds. The defense is encryption at rest, and modern operating systems bake it right in. You will see full disk and file-level encryption built into the major desktop platforms, alongside open source options that work across systems. When you evaluate tools, the differences that matter are how they protect keys held in memory, whether they encrypt the whole disk or just a volume, and whether they tie into hardware. And do not overlook smartphones, since the major mobile platforms include enterprise-grade encryption for the data they store. What does a trusted platform module add to that protection? A trusted platform module is a dedicated chip on the device's motherboard that stores and manages the keys used for full disk encryption. Its real value is binding. The module only releases the keys to the operating system after the user successfully authenticates. That closes a nasty attack. Someone cannot simply pull the drive out of your laptop, drop it into another machine, and read it, because the keys stayed locked in the original device's chip. Think of it as a key safe welded into the hardware, one that only opens for the rightful owner. So how do you decide what security an email actually needs? Match the protection to the requirement, and do not overbuild. Start with a simple decision tree. If the message must stay private, encrypt it. If it must not be altered, hash it. If the recipient needs to confirm who sent it and that the sender cannot deny it, apply a digital signature. And when you need the full set, confidentiality, integrity, origin, authentication, and non-repudiation, you both encrypt and sign the message. Remember that the sender owns the responsibility for putting the right mechanisms in place. Choose the lightest combination that meets the actual need. How does pretty good privacy build trust between users? Pretty good privacy, or PGP, is a long-standing secure email system with a distinctive trust model. Instead of relying solely on a top-down authority, it uses a web of trust. You become trusted by one or more existing users, then you extend trust to others based on their judgment, and trust radiates outward through the network of people vouching for one another. PGP comes in a commercial edition and an open source variant, and both support modern encryption, hashing, and signature standards. Picture a circle of colleagues who personally vouch for newcomers, and each vouch widens the circle of people you can trust. What makes MIME different? MIME has become a de facto standard for encrypted email, and it takes the authority-based path rather than the web of trust. It relies on X.509 certificates to exchange keys, using the public keys in those certificates for digital signatures and for setting up symmetric keys for longer sessions. Anyone can verify a signed message using the sender certificate, but to encrypt your own mail or sign it yourself, you need your own certificate. It enjoys broad support in major desktop mail clients, though mainstream web-based mail typically needs a browser extension to handle it. Where PGP grows trust person to person, MIME leans on the certificate hierarchy you already know. So let's bring it together. Applied cryptography starts with protecting data at rest on portable devices through built-in disk encryption, reinforced by a trusted platform module that ties keys to the hardware and the user. For email, you match the mechanism to the need, encrypting for privacy, hashing for integrity, and signing for authentication and non-repudiation. Pretty good privacy builds a peer-to-peer web of trust, while MIME leans on X.509 certificates. Master these, and you can secure real devices and real messages with confidence. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.